you're watching this, that means that I'm absent. For 3B and 4B, sorry, I'm not going to be here today. So what I'm having to do is I'm going to record myself going through the first 6 questions, if I can count to 6, of the pepper moth activity like I did with my A-Day classes and my 2B, because I don't want you to be just stranded. So the main point of this lesson today, and what we're going to do, is we're going to continue building on natural selection, except today the plan is going to be, we're going to be practicing our data and graph reading skills. We're going to be looking at graphs and data to see how those things can be used to determine which traits and adaptations are the most successful. So what I'm going to do first is I'm going to open this background reading that y'all do not have to read completely, provided the link works, that is. I'm going to summarize it so that y'all won't have to be stressed about reading it. And then I will do the activity with you one-on-one. So let's start right here. So I'm going to summarize this. If you want to read along, feel free to, not required though. So basically what you need to know is there's a kind of moth in England and North America. It's really common. It's called the pepper moth. So the peppered moth comes in 2 forms. You have a typical form that's kind of a light color with some dots on it. Looks kind of like pepper, right? But then you have another form they call the carbonaria form. It is a dark form. So you have light and dark. So what's neat is, unlike a lot of creatures, besides the colors, peppered moths, they don't have a lot of other differences. Those are the main phenotypic differences between them. That's what mainly what's different. They can mate and interbreed, and the colors are their main trait that's different. So they all live in the woods. It could be near people or far away. They usually turn into like pupae during the winter, and they hide in the ground. They pop up as moths in the spring. So what they do is they fly around at night and look for food and mates. During the day, though, they're chilling, so they hide on trees. The thing is, though, is on those trees, you got birds, and if birds see a moth, they're probably going to eat it. So some trees, as you can see in this picture, have this kind of light white, like peppery gray stuff on them. It's called lichen. So the lichen gives it this peppery appearance you see here. But some of the trees, the bark is super dark. It doesn't have that licheny look. So some of the trees are dark. So in the 1800s, there was this thing called the Industrial Revolution. You should have learned about that last year in 7th grade history. So during the Industrial Revolution, people started noticing that, those dark moths are becoming a lot more common. What's going on? And they were like, maybe all this smoke and stuff we're putting out is causing these moths to change color. But in typical fashion, everybody saw that, but just, ignored it until about the 1950s. Somebody went, we should probably maybe look at this. And somebody else across the room drinking their Coke or something went, yeah, and they finally figured it out. So scientists did some research from about 1973 to 1997 and collected data. And they figured out that, over about 24 generations of moths that they would change, the population would change. So let's go from here. And we're going to, so I want y'all to do it if you wouldn't mind. You can mind, but I'd like you to do this. Let me hit back on this. What I really like y'all to do is, if you're able, I don't know why I said you're able. Y'all are completely able. But I'd like y'all to read through this first little data set here under the assignment when it loads. And just to give you a little more background. So do me a favor, pause the video real quick and read that data set. And it tells you basically about how the air pollution in the Industrial Revolution, what it changed about the trees and the area. So I'll give you a second to pause. Okay, so hopefully you paused and read a little bit. If you didn't, that just sucks, but whatever, I'm not here. So basically, the first question it asks you is, what's the trait of interest in this study? I bet y'all can tell me it's pretty easy. As we said earlier, there's only one trait that's different, and that's the color. The color of the moths is the only trait that we are interested in because that's what we can observe. And as you can see by these graphs here, we observed a lot. So you should have that for number 1. Let's go to the next one. So it asks, what are the variations or differences for the trait in this population? I'll give y'all a second to think. Maybe write if you want. So if you thought about it, we said that there, as I said earlier, with my mouth, there's only one main difference, and that's that there are dark moths and light moths. That's their only difference, is some are dark, some are light. There's no big other thing going on here. And that's number 2. Number 3. It asks, what is the proportion of those variations in 1973? So y'all have read graphs before. So on your test, you will usually only be presented with one graph. But in this case, you have 2. One here and one here. So what you need to do is, we need to figure out which graph we're looking at. So the question says, what is the proportion of them in 1973? If you look, only one of the graphs has 1973 on it. It's obviously the first one. So what we're going to do is we're first of all we can zoom in on this graph by 1973. So it asks for the proportion. I don't know if y'all know what a proportion is, but if you've probably heard it in math. So proportion is, somebody yesterday compared it to like a sum almost. A proportion is like it's a kind of a comparison, or like two numbers that relate to each other. I think of them almost like you add them together to make one thing. So our proportion would be the number of light moths we have versus the number of dark moths. So in order to find that, we need to read the graph. So we're going to zoom in on 1973. And the graph is not exact. So we're going to have to kind of do some estimating here. So look at that 1973. Look at that dark moth there. Dark moth on 1973, where the dark line is. I would guess I'm thinking that line is probably at like, say probably 80 to 85%. So we have 85% dark moths. So for this one, I would write first 85, the proportion is 85% dark to, now we got to find the light. So if you look at the graph, you can see down here, once again, not exact, but I have some good news for you. If something is proportional, it means it needs to add up pretty equally. So with percentages, I bet y'all can tell me, if you have a population of moths and you measure all the moths, then the number of dark and white with percentages, if you're looking for the whole population, the two numbers should add up to what number? If you said 100, you're good. So when you're doing percent, the whole population is 100%, so we need to make sure they add up to 100. So 85% dark to what percent light? I think y'all's math is okay. It'll be 15% light. So in 1973, as you can see by this graph, they found that 85% dark of the moths they found were dark that year, 15% were light that year. And as you can see by the graph, though, as you keep going, that starts to change. Let's find out why. But right now, if you had to guess, I wonder which one y'all think would be best adapted for the environment. Let's find out. So we got the difference in proportions in the different year. So we got that data, we analyzed and sorted that data. Now we got to sort data for the different areas. So if you look at the different areas, there were 3 areas. They had an industrial one, where there's going to be a lot of pollution, and the trees would probably be more dark. You have an intermediate area, where the pollution's only from the house, there's not a factory. So there's some dark trees and some pollution, but not just a ton. Then you have the rural area, where there is no one living there. So there's no pollution hardly at all. And as you can see by this graph, that change had some pretty drastic effects. Let's find out why. Let's see what we got. So what I'm going to recommend you do, since we want to know each area, let's make it easy. I know it says essay, but I don't know about y'all, but I love a good bullet point. So put a bullet point and put industrial, if I can spell. So if we look at the industrial area, we got to guess our graph again. So we're breaking down this data. So under industrial, you can see that I'm going to guess, I don't know about y'all, I'm thinking about 65% of the moths, there were 90 of them, by the way, were dark. So we can put 65% were dark. And then we can put 2. So once again, if it's proportional, we got to add up to 100%. So let's think. 65% were dark, then what percent would be light? If you said 35, you are smart. So 35% would be light. So we got that one down. Let's do intermediate. So in the intermediate area, notice, there's a change. There's more light moths there. So remember, we'll break down what that means in a second. So intermediate. let's do the white, the light, the dark first, like usual. So I don't know about y'all, but I'm thinking the dark's probably like, I'm gonna guess real hard here. I'll say like 37 because it looks like it's a little above that 35 we said. Let's do 37% dark. So now you gotta do some hard math. What would you get for 100? What would you have to add to it? If you said 63, you're good. So about 35. This is, like I said, these are not exact numbers. They're estimating, but we don't really need exact numbers to see what's going on here. So that's intermediate, 37% dark to 63% light. Last one is rural. So in the rural area, remember I told y'all there was not a lot of pollution. It's pretty clean. So in this rural area, you have like, I'm going to say, I don't know about y'all, I'm thinking like 1% dark because there's like no dark there. That's wild. 1% dark, I wonder why. And I would say 99% light because it adds up. So we have now broken down the data. So let's think for a second. From the data, we've noticed that in the industrial area, where there's a lot of pollution, it's real dark, you have a lot more dark moths, less light. But as you go over to areas when the pollution starts to lessen, a lot less soot in the air, a lot less dark trees, more of that lichen we talked about grows. You have more light. Take a second to think, why do you think that dark survives better where there's more pollution and it's darker trees, and light survives better where there's less pollution and lighter trees? Did you figure it out? If you said it's because they blend in, that's right. Remember, with natural selection, the trait that's best for the environment is what gets picked. So the dark ones where on a dark tree, they blend in, so they don't become food as often. They get to reproduce. There are more of them, as you can see by that graph. But over in rural, where there's not a lot of pollution, the light ones, the trees are lighter, there's more lichen on the trees. They can blend in, they survive and reproduce. They thrive. So if you were looking at this graph and I didn't tell you all this, if you had a graph like this on a test, my goal would be that you would be able to go, okay, on this rural graph, the light moths are surviving and thriving. That means that they must be the best adapted for that environment. And if we're in industrial, we could look at the graph and say, okay, dark is surviving better. They're the best adapted for the environment. And that whole thing is called natural selection. Okay, I don't think I'm going to do 5 and 6, y'all, but I'm going to give you a hint. So, I'm going to give you a prompt to go off of for 5 and 6, and then I'll say solution your own. So for 5 and 6, I would do what you did before. Write industrial, intermediate, and rural. So this question's asking you, what do you think the effect of having a lighter speckled color, if you're a moth with a light color, how would you do, basically, how would you live in each area? I'll start you off with industrial. If you're a light moth in the industrial area, I want you to tell me, do you think you would survive really well? Or do you think you would survive not so well? If you said not so well, you're good. Because if you are a light moth on a dark surface, like a tree, like here, this moth, it's not a moth, but look, a sucker don't blend in. You can see it a mile away. So if you don't blend in, you are way more likely to become lunch. So for industrial, you could write the light moth, you could write like something like light moths would not survive well, because they do not blend in. And because they don't blend in, they don't get to reproduce, right? They don't get to pass their offspring on as often, or their genes on as often. But if you're in a rural area, right? I'll just do number 5 with you. So, in an intermediate area, would they survive pretty bad, or would they be a little better survival? What do y'all think? Based on that graph, would they survive really bad, or would they be a little better? Intermediate. So if you said they'd survive better, you're right, because if you look at the graph here, they survive a little better there. So I would say light moths survive better in the intermediate environment. And you gotta tell me why. Otherwise, there's gotta be a reason. Because less pollution. Think about it, less pollution means more light trees. All right, with this last one, rural. I mean, there's no pollution, so all the trees are light. So moths would survive what? Best in that environment. I'm going to introduce a word to y'all to make sure y'all know how it's used. Y'all probably heard the term survival of the fittest. I'm going to use the word fit in my last answer. So the moth, light moths, obviously killing it in rural. So I'm going to say the light moth would survive best in rural areas because its adaptation to make it the best fit for its environment. Make it the best fit for. I'm bad at typing, y'all. So, when you're fit for something, you're good at it. Like, for example, I'll call somebody in my, who plays sports? Who's somebody that plays sports? Like, for example, I gotta find a football player in my mind somewhere. I'm gonna just call out Langston. Like, Langston plays football. So that means that if he plays football, he's probably in shape. He's probably at least reasonably fit for the sport. So, if you're fit for it, then you can actually play it. Like me, if I go out and try to play football, I'm probably gonna get murdered because I'm not at all fit for football. I'm gonna get killed. So, just like that moth, it's light colored, all the trees are light. It is the best fit for its environment. It's gonna survive and reproduce. So, if an organism is surviving, then it is the best fit. And as you can see on this graph, that moth is excelling. There's tons of that white moss. That means that it is the best fit. So, going forward, the number 6, it's going to reverse this and ask you about dark moths. I want you to look at this graph and think, if it's a dark moth, then which environment would it be most successful in and least successful in? Same thing as you did here. Push your 3 bullet points and write out how it would do in each one. After that, 7 through 10, it is a new data set and 2 new graphs. And you'll do those on your own. I have one tip for you. One of the graphs is a scatter plot. It's got dots on it. So, make sure you pay attention to what is on the y-axis and what is on the x-axis, because that will help you read the graph. Make sure you submit this assignment by the end of class. That is 1:45 for 3B and 3:15 or so for 4B, because I will check the grade book at that time. And if you haven't submitted, I will drop a 0 in, and it'll be minus 10 points because this is a classwork assignment. So make sure you get done. Use the graphs to your advantage. That's the goal. Is if you see that an organism has a higher number of population on the graph based on it with a certain trait, it's probably doing the best. We'll have some more checks on this later. But hope y'all go for the sub. Hope y'all have a good day. See you later.